approximate the area under the function f of x based on the given table values. We're going to use the left-hand approximation method. That's important to note. And we're also going to have 4 equal subintervals. So, step number 1 will be to determine the interval. And we do that by calculating delta x, which as you know by now is b minus a divided by n. What may be confusing is where do we use for b and what do we use for n, a. So b will be the end of the interval right here, 4. Okay. A is where the entire thing begins for our table. That's going to be -4. And we tell you that our 4 equal subintervals, that's going to be our n. So when we plug in and evaluate, we're going to have 4 minus -4 divided by 4 gives us our delta x is 2. So just to give you a visual on the table, the entire table starts at -4 and ends at 4, but the subintervals are going to be at every 2. So we go over 2 and create our subintervals, and you'll notice that we have 4 subintervals. Our next step will be to set up our LRAM, left-hand approximation. So the L, the left means that's where the interval starts. So the height, let me just erase some of these highlights so I don't have clutter here. Might get a little too cluttered. There we go. So to calculate the height, it's going to be f of the particular value. So this begins at -4, so the height is going to be f of 4. The next interval begins on the left side at f of -2, and then our next interval begins at f of 0, and then finally the final interval begins at f of 2. So that's how we end up with the area is equal to f of -4 plus f of -2 plus f of 0 plus f of 2. Our next step will be to evaluate. So we see that f of -4 is 41, f of -2 is 24, f of 0 is 14, f of 2 is 11. That's also given by here at the table. And evaluating that out, we find out that the area under the curve is approximately 180 square units. So the correct answer is B.